And welcome back, everyone. In this video, we're going to start the process of going into conditional coding. What's a conditional coding? Well, you know how before I had the lines of code, or the visual lines of code, just go step 1, step 2 like this? Well, in conditional lines of code, you can have a situation where if the condition is met, it'll go one way. If a different condition is met, it goes another way. So instead of going line 1, line 2, line 3, line 4, we might go line 1, line 2, line 3, or we might go line 1, line 2, line 17. Something like that. And that's what's known as an if statement. Now, and it's also known as conditional coding. So what I'm going to do is I'm going to just change the shape here, just to distinctly signify that this is something different from something else. And you know what? I'll even change the color. So I'm going to go over to this little tab over here, and I can go and change the color to yellow or something. Also, if you need to, it's under the View Format panel, and you can click View Format panel, it comes back on. So this is basically our if. Our if. Now, what do I mean by if? Well, think about it like this. If something happens, then something else will happen. So, if you're playing a Mario game, if you press the jump button, Mario jumps. If you don't press the jump button, does Mario jump? No, because you didn't press the jump button. So there's two possible outcomes. Outcome 1, outcome 2. Wait a minute. There's only two possible outcomes. It's almost as if an if statement is binary. It has true or false, yes or no, 1 or 0. It's machine language. This is essentially the basis of all coding. So, if we have an if that goes one way or the other, we can now start compiling things and start making things that are more than just a book report, more than just step 1, step 2, step 3, step 4, step 5. So, there's a really good example of this for anyone that remembers this game, Lightbot. Lightbot images here, because I'm pretty sure it's a downloadable program you have to buy now or whatever, but basically, this is Lightbot. Lightbot is, the program goes forward, 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 light bulb, and it will literally go forward, 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 light bulb when that happens. It's literally click and drag these cute little shapes into the code, and it'll go line 1, line 2, line 3, line 4. It's essentially visual coding. You might have seen this game in the hour of coding, or in your middle school coding class if you ever had one. It's generally used as a tool for the same sort of situation. Now, this is generally the same thing, except instead of using, a little cute little robot, we're using, shapes. It's still visual interpretation of code. And it'll happen in a certain order. Step 1, step 2, step 3. If we come to a branch, there's a condition. And that condition will then, branch off into two possible outcomes. So let's actually make an example of this. So I'm going to assume that we're a racing game. And every racing game, has a start point, right? The green checkered flag, or not the green checkered flag. It has itself, the start, red light, green, and at green you go. And then, what is it you do? What is the only thing you do in a driving game? You drive. So we're going to drive. And we'll just do it like this. We'll have it so it's, line 1, line 2. By the way, if you ever get worried when you're making something of this of your own, if you just go off the page, it'll make a new page for you. It'll be perfectly fine. So you can move things around and see them how you see fit. So then we have ourselves an if question of some sort here. Okay, we're driving. What exactly should we check for? Well, we should probably check to see if we cross finish line, right? if we cross the finish line, right? If yes, we have to do something, but if no, what is it we do? Well, we haven't crossed the finish line, keep driving. So obviously, this is no. So if no, we go back to keep driving. But if yes, we have to check something else, right? Did we cross the finish line? What does that mean? So if yes, we cross the finish line. So if yes, by the way, I'm just simply double-clicking on items to start typing. So if yes, what should we probably check for? If yes, let's think about this for a moment. If we cross the finish line, well, is it lap 1, lap 2, lap 3? So we should probably check this. You know, is this lap 3? If no, well, you know, obviously we got to keep driving, but you know, let's just add a let's just add a little thing here. And why I'm picking different shapes and different colors will become apparent in a later video, but I just want you to realize that I'm doing this now just to remain internally consistent. So if no, well, we still need to add 1 to the lap counter, right? Because lap 1 becomes lap 2 becomes lap 3, so on and so forth. And then, you know, eventually it'll just go back to keep driving. So add 1 to the lap counter, boom, and keep driving. So if it's not lap 3, no, we add 1 to the lap counter. But if it is lap 3, oh, that means we have to do something else, right? Now we have to check something, right? Because if it's lap 3, the race is over. Is it lap 3? Okay, well, race is over. What do we check at the end of the race? We check to see if we won. So are we in first place? And now there's 2 possible outcomes we could have from this, and I will just pick a this guy right over here, because it's the closest thing I have to a stop sign to make red. There's a you win, actually there's a you lose, and there's also a you win. Either way here, that's the end of the program, right? We either win or we lose. So if we were in first place, no. If we were in first place, though, yes, we win. And that's basically just a sample of a game, just the basic overview of coding. You start driving. If you cross the start/finish line, you know, if not, keep driving until you do. Keep driving until you do. Keep driving until you do. And then, but when you do cross the finish line, oh, well, is this lap 3? If no, we add 1 to the counter. But, so, you know, it goes from lap 1 to lap 2, keep driving. Goes from 2 to lap 3, keep driving. But is it lap 3? Yes. Well, then the race is over. Are we in first place? If no, we lost. If yes, we won. Very simple concept of just branching logic. These right here, these triangles are my triangles. These diamonds are my conditionals. They are conditions. Condition 1, condition 2. Condition yes, condition no. Condition true, condition false. They are just literally 2 possible outcomes. Condition A, condition B. Now, we could have many, 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 many conditions. If you look at it kind of this way, this is kind of 3 conditions in a row. If you want to think of like a tic-tac-toe game or something like that, you can have a, you know, if we think about it, there's, you know, 9 different blocks, so you can check to see if block 1 is an X. And then you can check to see if block, you know, 2 is an X. Or you could check to see if block 3 is an X. Or you can check to see if block 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth. And if you really think about it, there's, you know, there's 8 different ways you could win. You could win, you know, left to right, or you could win left to right in the middle, you can left to right in the bottom, or you can go up and down in the middle, up and down on the right. You can do diagonal left, diagonal right, so on and so forth. There's 8 possible ways. So in theory, you could have if this is x, and if this is x, and if this is x, you win. Or if this is x, and this is x, and this is x, you win. Or if this is x, and this is x, and this is x, you win. Or if this is x, and this is x, and this is x. Or if this is x, and this is x, and this is x. Or if this is x, and this is x, and this is x. Or if this is x, and this is x, and this is x. Or if this is x, and this is x, and this is x. Or if you're one of those people that played corners, if this is x, and this is x, and this is x, and this is x, you win. Which would be 9 possible ways. And then you'd have to calculate that same sort of concept for circle as well, because there's x and o. So obviously, we could get ridiculously complex with the number of if statements we have in a row here. Really, I just went through the entire basic logic of a racing game with a grand total of 3 different questions, asking 3 very specific questions. And those questions are those branches in logic. Maybe the add 1 to the counter is not on line 4. Maybe that's on line 87. Well, then it goes to line 87 and it goes back up to line 2. That is conditional logic. That is an if statement. And this is the beginning of breaking code down into visualized concepts that, move on. Now, I've actually already shown you a little bit of the next video right here with this drive and this right here. So, in the next video, we'll be talking about loops. Hope you have a fun day. See you in the next video.